Hello, students and learners. You are welcome back to Library Premium Consult. In this series of videos, we are looking at introduction to statistics. So please, if you are new on this channel, kindly consider to subscribe, like, and share. So, under introduction to statistics, we are looking at actually correlation and regression. And this slice of PowerPoint that actually I'm using is being credited to a lecturer in Kenya's School of Business, Dr. Emmanuel Kwanzaa, for his good work, and actually that is the slides I'm actually using for making the presentation. That this slide is coming from Dr. Emmanuel Kwanzaa, a lecturer in Kenya School. So I say a big thanks to you, lecturer, doctor, for allowing the slides available for us to use to make presentation, to teach you guys to understand certain basic concepts under statistics and mathematics in general. So thank you, doctor, for availing the slides. So guys, let's continue to look at correlation and regression in this case. So somebody may ask, what is correlation? So another, you're going to look at correlation. You're going to look at overview of correlation and regression. We look at correlation, the meaning of correlation, some terminologies, scatter plots and correlation itself, then characteristics, correlation coefficient, then we look at regression in that case, then correlation and regression, how are they two related, then simple regression analysis and linear regression model or equation. So that is what we're going to look out for in this, as well as the general overview that we're going to look at under correlation. So somebody may ask, what is a correlation? What will be your response? So you are saying that correlation is a statistical method used to determine whether a linear relationship exists between any two variables. Exists between what? Any two variables. So for example, taking the height of what? A parent and their offsprings. There are times you can see that you have certain friends in your life that you can see that looking at this person, you see this person is very tall. Let's say the tallness as one feature of the height that we're talking about. You can see that this person is very tall. Then you may ask, well, why this person so very tall like that? Then you do a proper investigation and you clearly see that, okay, their parents are very, very tall. And you can see that it runs through their families. You can see that these people, that friend that you have, you can see that all their parents or all their family members are very, very what? Tall. You can clearly see that on that basis, there is this pattern that has been what? Established between the parents and their what? Offsprings in that case. So you can see that there is this what? Linear relationship. You can see that all those who fall under your friends that you're saying is very tall, all his family members are very tall. So you can see that everybody is also, there's this what pattern that has been what established between your friends and what his parents or other family members that you actually have. That's what correlation is trying to tell us. It tries to, a statistical method that used to determine whether there is a linear relationship that exists between what two what variables. Okay, so that is actually the correlation. And you can also see at times too, you can see using the same height, you can see that you have certain group of people who are very, very short. Okay, but then when you trace and do proper investigation, you can clearly see that okay, their offspring too, you can see their parents are very, very, very short and cute. So in that, you can see that a majority or 70% of their offspring is very what short. That is what correlation actually try to what help us to determine that if there exists this linear pattern or this relationship between two or more variables, then we can actually look into it and understand why this relationship or this pattern exists between what these variables that we're actually talking about. So height can be an example of what, a good example of what a correlation in two variables, taking parents and their offsprings in that case. So that is actually a correlation. So we are saying that correlation used to answer the question like, are two or more variables related? As I was using the parents, the height of a parent and their offspring. So you can see that there is this what linkage, there is this pattern that is being established. So you can see that they are related in terms of their tallness or their heights. This I get it, or let's say their shortness or their cuteness. So that one can also be what established. Then also, if the answer is yes, if so, what is the strength of the relationship? So actually, is a strength that will determine whether there is a relationship between two variables or there is no. And as we move along, we understand the strength relationship in this video. So that is what correlation is actually talking about. Two or more variables are related, and what is the strength of the relationship in that case. So as we move along, you appreciate more of the correlation. So in that, we can have some familiar examples. As I was saying, correlation phenomenon that can be a correlation between the height of a parent and their offspring. So you can see that, as I was saying, the height of your friend, you can see that this friend is very short, this friend is very tall. Can we understand from the perspective of his tallness or his height, his tallness or his cuteness? Then we'll do a proper investigation. We'll go down and research and find out that okay, their offspring, their parents, their family members are very short due to this and that and that. So in that, correlation will help us to understand the reason why that your friend is short or tall. Because it is a statistical method that will actually help us to understand why that friend is very short or tall. So these are the practicals that correlation actually dealt with. So the height of a parent and what their offspring can be one example of a good correlation. So it helps us to understand a pattern that exists between the parents and their offsprings in that case. And a correlation between the price of a good and the quantity of consume and the quantity the consumers are willing to purchase. Yes, this can also be what established. The fact that there's this perception that individual might think that when we have this kind of product, this kind of good in the market, and looking at the quality level, people associate that quality will actually increase price. We understand quality will actually increase price, but the fact that the quality is causing the price to increase, that doesn't mean that correlation is actually what causation. Cause I'm saying the fact that the quality of the product is very high will not necessarily cause the price of what the product to be very high. There are times you may have the quality of the product to be actually very high, but then though in real life situation, quality will actually what increase prices. But then that doesn't mean that once the quality is increased, it will cause the price will cause to increase. That's not what correlation is actually about. Correlation is about, let's say, looking at the price and then the commodity. Actually, we have certain consumers, okay, that irrespective of the quality of the product and their price, they will still buy. It's not that the quality is actually causing the price to increase, that's actually is buying, or the price is increasing because the quality is high, that's actually is he or she is what buying. But then because of what the, let's say, the needs of that consumer, that will actually necessitate for him or her to buy that product. So it's not actually the quality of the good that's actually causing the price for him to actually buy the product, right? But then it's actually the needs of that what consumer. So that is actually what correlation tries to talk about here. Actually, it'll help us to know why this product demand this price. Why that product demand? Is it from the side of the consumer who actually wants? That's why. So that is what correlation actually try to establish. It helps us to understand why having this kind of product, there is this pattern that once we display this kind of product, people will actually come and buy it, and there is this product that will be there in the market but no one will buy it. For example, taking BB bread in Ghana, you can clearly see that, or A1 bread in Ghana, you can clearly see that once these bread are in the market, people are actually willing to buy this product. Why are actually people always rushing to buy this kind of bread and to use it? So in that, we can actually establish a clear cut or a clear relationship why people actually prefer to buy this product better than other products. That is what correlation is actually want to talks about, or actually want us to understand. So always, if that is the case, then there will be what a pattern that will actually use. So as statistician, based on that information, you can clearly make some predictions, and then that's when we are into regression. Can clearly make some information, do some background information, then establish why people actually prefer to buy this kind of product better than others. So in that, you can clearly establish what a pattern of what the relationship that will exist between the quantity of the good that the consumers are willing to buy, and then price of what the commodity, but not necessarily the quality actually causing the price to increase is what correlation is about. But correlation is not about causation. So let's take note of that in that case. So that is actually another aspect. We can even look at an example as we move on. We have a whole lot of examples. So correlation, so these are the actual advantages of understanding correlation and how you can actually apply it. These are some of the benefits that you can actually derive when you actually engage or when you learn correlation, statistical method that you use to establish a linear relationship. This is how you can actually apply it in your life. So correlations are useful because they can indicate a predictive, right, relationship that can be exploited in practice. So that can be exploited in what, in practice. For example, an electricity utility may produce less power on mill day based on what the correlation between electricity demand and what and water. So you see this. You see, we have electricity utility that actually we use in our daily lives, like lights. Yeah, lights in general. Let's use lights as we use in our various homes and businesses and even institutions. And this is what example is saying. Electricity may produce less power on mill day based on the correlation between electricity and what water. So they can clearly see that on the mill day, when electricity demand and weather are into what relationship, what are we trying to understand here? What is correlation trying to predict from these or two variables? You can clearly see that at times when the weather is very cold, people may use a whole lot of what, or people may consume a whole lot of what electricity. The utility of electricity will increase. Okay, but then when the weather is very hot in a normal base, actually, for example, to maintain coldness, nobody will be willing to use electricity because actually the day is very hot. So why the weather is very hot? So why then using, let's say, lights to heat up? When you even do that, you are even increasing the temperature of heatness, isn't it? Yes. So here, what I are trying to say here is that there is another factor: the usage of what people will actually necessitate will cause electricity utility, right? Electrical utility to actually what increase. People are using what electric gadgets because the coldness will also be another factor that will actually cause people to what to use what high electricity, right? In that case, but then we are not into causation. We are not into, as we move along, you understand this example, there is what a causal relationship, but then we are not all that we are trying to understand here is that what is the relationship between electricity demand and what the weather. So you can clearly see that as the weather changes, when there is a cold, people will use what high electricity. When the weather is hot, people will use what the assumption that people will use what less what electricity, isn't it? So in that we can see that there is a relationship that, or there is a pattern of relationship that exists between electricity demand and what the weather, isn't it? But then we are not into their causal side where people will use more or that. But we are trying to understand from the perspective where whether there is a coldness or whether what is the relationship between electricity demand and their demand, electricity demand. Yes, what is the relationship between the demand of electricity and the weather? So that's what we actually want to understand. So here in the above example, there is a causal relationship because the extreme weather causes people to use more electricity, as I was saying, for heating or what cooling. But then that's not what we actually want to talk about. We are not into causal relationship. As I said earlier on, correlation is not about causal relationship, but correlation is about what kind of pattern will exist between two or more variables when they are into what play or when they are what related. So as we were using the electricity and the weather, you can clearly see that when there is coldness, a whole lot of what people will use high electricity, but when there's hot weather, people will not actually use more electricity or light to actually, let's say, body temperature. I Please, are you trying to tell me? So in that we can establish that what relationship between the two in that case. So Let's take note of that. So correlation is not about causation. Correlation is about pattern that will exist between what? Two variables. Okay, good. And then, so however, in general, so this is what we are saying. However, in general, the presence of correlation is not sufficient. So in that, if you want to understand better about two or more variables in their relationship and how they affect each other, correlation wouldn't be sufficient enough. Once you know the pattern that exists between two variables, won't actually help you to make a better conclusion that actually these two variables react when they are what into relation. No, it's not sufficient. So to infer the presence of causal relationship, as we are saying, correlation does not imply what causation. So please take note. Correlation does not imply what causation. So let's take note of that. So that is a brief introduction about correlation in that case. So you can look at some terminologies under correlation. You can look at dependent variable. We call dependent variable or a response variable, right? Dependent variable or a response variable or an outcome what variable. These are the things that we can call. So we are saying that this variable is a variable that will actually change as a result of a variable that will influence it toward change. Okay, so for example, taking a performance of a student and their learning habits, you can see that at a particular point in time, when a particular student learn at a very high rate, all things being equal, we expect that his performance will increase in, let's say, examination, statistics exams paper. A particular student learn the statistics. I mean, he took his lectures serious and studies very serious. So at the end of the day, he performed very high. So you can see that once you study hard, your performance will increase. That is the assumption, and that's why we call the outcome is what we call the dependent what variable. But the one the studies or your learning that you actually learn will become what we call an independent what variable. So independent variable, there are those variables that will actually influences another variable. So that is an independent. We can also call it an influencer variable, or can call it once influencer variable, or let's say a predictor variable. Is how you get what I'm saying. So that is the two. So dependent variable will change as a result of changing another word variable. That's the independent variable. And the independent variable is the one that causes or influences another variable. That is the dependent word variable. So that is the two in that case. Then we have a scatter plot and what correlation. So this is also another statistical tools or statistical arrangement that we actually use to determine a relation between two variables. So if you have two variables, let's say variable x and y, then we plot them on a graph. We want to establish the relationship that exists between variable x and variable y. And to the scatter plot, you can know that there's probably a direct relationship between x and y, or an inverse relationship, or there's a partial relationship. We can be direct or inverse, or there is no what relationship between what two variables. It is through this scatter diagram that will help us to know that this relationship exists between two or more variables. So that is a scatter plot or a scatter diagram. We call it scatter plot or scatter diagram in that case. So let's take note. So as we move along, we'll dive deep to solve more questions on how these graphs or plots works when it comes to determination of correlation between two or more between two variables. Let's use that one for purpose of understanding. So this just a diagram showing a relationship between two more variables. For example, the number of sales that actually, let's see here, the y part is the number of laptops sold and number of sales calls that actually you made. So we are trying to determine the relation that will exist between the number of calls that you made and how much can you sell for a particular day. So number of calls that you made will determine the number of sales that you can make. So if you make more calls, the assumption is that you're going to sell more for laptops. But if you don't make enough course, you won't sell a laptop. So in that, you can see that here, this line, there is a positive relationship between what the number of course that actually a client will made and the number of laptops that you can actually sell. There's a positive relationship because as the number of course increases, that client is able to sell more of what laptops. But then as his decrease, he sells what less. So that is actually a positive relationship. And we get to understand this positive relationship or this inverse relationship or partial relationship that actually I'm talking about, and the meaning that they have a specific names or terms that we use for them. So as we move along, you understand it better. So let's move on to characteristics of correlation. So having we said that correlation is about what a statistical method used to determine a pattern of linear relationship between variables, then we should be able to know certain features that once we see that feature between two variables, we can determine that there's a correlation or these variables, there is a correlation between these two what variables. That's why we're going to look out for a feature or a card, something that tells us that these two variables are correlated. So based on their character, we can know that these two variables are what correlated. That's what we're going to look at in this video. So let's take note of that. So as we are saying, a correlational relationship has a specific characteristic which enable us to determine the type of correlation as well as the strength of the correlation. Yes. So once we're able to know that there is a correlation between, it can also help us to know the strength, whether it is a positive, a negative, a partial, whether it's a partial in positive or partial in negative, or there is no correlation. That's what we're going to look at in this. So we are looking at the positive. For a positive correlation, there are those correlation if so that's what we're saying. A positive correlation are those correlation which when one variable changes cause a change in another. And most of the time, positive correlation leads to an increase, right? Or a decrease in what? A variable. As one increase, another will increase. As one decrease, another will what? Decrease. That's a positive correlation. So we are saying that as one variable increase, so does other. If one variable reduce, the other variable also what reduce. That's what we are saying. So this is indicated on the scatter plot as well, an upward sloping straight line. For example, like what we are having here. So this scatter diagram can be a form of what? A positive correlation. The negative correlation will have its line to be look like this. Look like this. The line I'm trying to this line look like a backward sloping line. So as one variable increases, another variable decreases. All right, so that is a negative correlation in that case. So in a negative correlation, one variable increase and other decrease, as I was saying. Thus, high values of variables are associated with low values of what other variable. This is indicated by what? A downward sloping straight line. So this is what I was saying, a downward sloping, as you can see on the screen, downward sloping like this. My diagram is not nice, so forgive me. Downward was sloping in that shape. So that's a negative correlation. A positive correlation will look like this. The one I've indicated. Let me use like this. This will be the red one will be a positive correlation, but then the black one will be what? Let me erase this. This one is not part. This red one will mean a positive correlation, and the black ones, the one I've indicated with the red, is not part of what I'm trying to teach you guys. The red one will indicate a positive correlation. The black down here will indicate what? A negative correlation. So let's take note of that. Then we have a perfect correlation. We have a perfect correlation. So under perfect correlation, it can be either a positive or what? A negative correlation. And a perfect correlation can be either a positive or a negative correlation. So if a relationship or a correlation between two more variables is perfect, the points in the scatter diagram will lie exactly. So that's why we are saying that if the relationship between two more variables are perfectly correlated, their values will lie exactly close to the line. For example, if I have this negative correlation line, right? Then I have these points. I have these circles or this line. You can see that this is called what? A perfect negative correlation. Why? Because the circles that I've indicated, or the dots that I've indicated, lies exactly or perfectly on the diagonal line here, which is what? A negative what? Perfect correlation. Okay. But if it's a positive correlation, it will be like this. Using the blue to indicate, and you have the circles very close to the line, to be like this, very close to the line. So that's what we call a perfect correlation. So a perfect correlation can be either a negative or a positive correlation, in which the variables or the values lies very close to the line, to the straight line we are trying to talk about. So it can be either an upward sloping or downward slope. If an upward sloping, then it is a perfect positive correlation. If they're downward sloping, then it is a perfect negative correlation. So let's take note. You can also have a partial correlation, in that it wouldn't be perfect, but then you get some of the lines that lies very close to the straight line, but then it won't be as good as a perfect word correlation. It is partial. I mean, the word partial, you can clearly see part of the values will be close, but then not all will be what close. So in reality, the relation between two variables is really perfect. But then let's see, that's in most cases the point variables. Let me erase this. In most cases, in most cases, the point variable will be lie close to the straight line, but not lie perfectly on it. Yeah, that's what we are saying is that most of the variables or values, sorry, will be very close, but not all the case that you get all of them close. So anytime you have two variables in which their value doesn't lie, so anytime we have what, a straight line in which there, or two variables in which the values doesn't lie very close to the line, in that whether it's a positive or a negative, it is called a partial correlation. And a partial correlation can be either a positive correlation or a negative correlation in that case. So that's, as we have done that one, is that if any points are clustered close to a straight line, the relationship is considered to be quite strong. As the point gets more spread out from the line, the relationship gets what, weaker. This is what we are saying. Gets weaker. Gets weaker line I'm trying to indicate. But then if it get close to it, then it becomes quite what, strong. Okay. So a partial correlation can be a positive or what, or negative, as I was saying in that case. So let's take note of that. So partial correlation, the values, you have some of the values that are close to the line, but not all the values are perfectly close to the line. But when it comes to perfect correlation, most of the values, you can say 70% or 80% of the values are very close to the line. So when you have a perfect positive correlation, it can be a strong positive correlation or a strong negative correlation. But a partial can be a little bit, when some of the values are close, can determine some quite strong relation. But then if they are not, those that are not, can determine some weaker correlation. Like, so partial correlation can be either a negative or what, a positive. So let's take note of that. And it works the same way in that case. And you have no correlation here, two more variables in which there is no relationship between them. And you can have a correlation like this, let's say x and y, and you may have something like this. You can actually determine a correlation in this case. You can say, so you can have something like vertical or horizontal, and what does it denote? Actually, there's no correlation in that case. So anytime you have such correlation, anytime you have two more variables in which there is no relation between their variables, then it becomes what, variables of no correlation. So take note. So there is no correlation or relationship between two variables if the scatter plot display a random scatter of points which are neither going up or what down. This means that the linear relationship does exist not does not exist between two variables. Sorry, was a mistake in that case. So that's no correlation in that case. So once there is no correlation, you can't tell whether it's positive or so. There is no correlation. It's neutral. So let's keep that one. It's neutral in that case. So in that we have some statistical tools or method that will help us to determine the correlation. Once we know the correlation between variables, it can help us to determine the strength of the relationship between the two variables. As when we begin with this video, we clarify that correlation, we can use some two questions to answer if two variables meet a correlation. First, there must be a relation between the two variables, and second, if so, there should be some level of strength between the two variables. And in that, anytime we are into determine the strength of a correlation between two variables, then we'll be using some statistical tools or methods like a product moment correlation coefficient. This method was derived by a man called Pearson. Pearson correlation coefficient. He was actually who came out with this method of determining what a correlation or determine the strength between two what variables. That is one. So product moment correlation coefficient. We are saying the product moment correlation coefficient, we use a small letter r, provides a numerical method of determining the type of relationship between two variables, whether positive or negative, and how strong the relationship is. As I was saying, that is the product moment correlation. It helps us to know the strength of the relationship and whether it is a positive or what a negative correlation. So it measures the strength of, as I was saying, the linear relationship. And then there is a range within which we can measure the strength of what two variables. So the range is always in between, is always in between -1 and what positive what 1. It's always in between -1 and what positive 1, as I've circled. So when the value of r is near, so if we have a correlation that is near to a positive 1, or that is getting close to a positive 1, we can have what a strong positive linear relationship. But then if it's close to a -1, then we can have a strong negative correlation. All right, but then if it is 0, there is no correlation, so you know that one. But then if it is farther away from a positive one, then there is a bit weaker, not necessarily weak. You get some weak correlation between the two variables. But then it's also, so that one can be a weak positive correlation. But if it's a bit closer to, farther away, sorry, from the -1, then it's also a weak negative correlation in that case. So there is a strong negative relationship, and those stuffs I was trying to say. If it's 0, then no relationship exists at all. So let's take note of that. So it is always -1 and then +1. Please take note. Let's take note of that. Good. So that's all. Here is just some graph presentation for what we actually explained. So if it is -1 or close negative, and it's very strong correlation. That's what I'm saying. There's very strong correlation. You can see these values I'm trying to talk about here. So these are what we are trying to talk about. It can be grouped into negative and positive, and if there is no correlation, it is 0 in that case. So it is always -1. If you want to present more, then use your r less or equal to +1. So -1 less or equal to r less or equal to what? 1. So that is the range for correlation coefficient, and represent as what? R. And the method that we use to determine that is what? Product moment correlation coefficient. Please take note. It is a product moment correlation coefficient, this one. Let's take note of that. Okay. So let's move on. So this is a formula that we use to determine a correlation coefficient. So you are saying as a correlation coefficient is just a numerical value that will determine the a strength and then a relationship between two or more variables. So if it is positive, then it's a strong positive. If it's negative, then it's a strong. I mean, if it's a negative one, that makes it a strong negative correlation. But if it's positive one, it makes it what? But if they are very close, then there's some quite strongness. But if they are farther away, there's some a bit can get moderate correlation in that case. But then that was explained in just the this slice that I was talking about. So you can actually learn more on that in that case. So this is how we actually determine correlation coefficient. R is equal to, so this is what you're saying, R is equal to sum of x minus y, so x minus x bar. Actually, I can't have it perfectly done, so don't, never mind. So this is actually the formula that we use to determine that. So you have a summation of x and x bar equals and y and what? Y bar. The y bar is the mean, and the x is the variable, the values for or the values of the variable x, and the y is the values of variable y, and the x bar is the mean of x and the y is the mean. So you know how to find the mean or the average. So once you find x minus x bar onto bracket, you are finding the summation of the two actually. Then you divide by the square root of the summation of x minus x bar all squared multiplied by the summation of y minus y bar all squared. So that is how we find a correlation coefficient, and we use a practical example to explain this formula much more better. So for now, keep this formula in head. As we move along, we solve more questions for you to appreciate this better. Then we have what we call coefficient of determination. So after knowing the numerical value to determine that there is this strong or negative correlation exists between the variables, you also need to know about what percentage of that variable contribute to influence another variable in this case. And if you are into that, then we are talking about coefficient of determination, a single value, right, or a single summary number that tells you how much variation one variable is directly related to the variation in another variable. It is called what? R squared. So for that one, R squared, after knowing your R from the correlation coefficient, you can just R squared it. It's always a percentage. It's R squared and multiply by what? 100. Then you are good to go. So to tell you how much variations actually one variable contributes or influence on another variable. So that is coefficient of what? Determination. So I'm saying that it's always after finding your coefficient of correlation, you square it, then multiply by 100 for us to determine the percentage contribution that one variable have in another variable. So that's why I'm saying there's a single summary that tells you how much variation in one variable is directly related to variation in another variable. So that is coefficient of determination. So let's take note of that. If you have any question, please kindly put them in the comment section and I'll give you response to that in that case. So let's move on. So this is a scatter plot and correlation coefficient values. I mean a summary of what we actually done. Correlation coefficient, we said that one measure the strength of the line, and the line I will always have, whether it's a positive or negative, partial or perfect, you can call it a line of what? Best fit, right? Line of best fit. If the lines are very close, then become a perfect line of best fit point, right? So that is actually what you can see. You can see a negative one, all the values here. This is what I'm talking about. All the values are in that, so you can see it's a negative correlation. You can see the values are line up. If you draw a line, you can get a perfect straight line. But it is so that one is a perfect strong negative what? Correlation. But if it's a negative strong correlation, and let's say negative 0.9, this one You can see some values falling off if it was to be a negative one, and it runs throughout. If you have a no correlation, then you can determine zero. Then as you move on to positive 2, you can see the values are lined up, and when you have a line drawn, you can have a perfect line as I've drawn here. So take note of that. So if the correlation is 1, then there is a perfect positive correlation. If it is 0, no correlation. But if it's negative 1, then there is a perfect negative correlation in that case. So let's take note of that. So that's 0 as to regression analysis. As we said, correlation is about what? Relationship between two or more variables. And how do we know that after knowing the strength, how do you know how well a particular variable can have an influence in another variable? How they can influence another variable? And when you are into an influencing variable, when you are into two variables in which when you're into two variables in which one variable influence another to change in another way, then we are talking about causation. And once you're into causation, you are talking about regression analysis. The analysis that we actually do to establish what a causation between what two variables, taking your learning habits and your performance. You learn hard, you perform very high. You learn at a very small rate or lower rate, you perform badly. So in that, what will help us to establish that relation that will actually cause a change between your learning habits and your performance is what we call the regression what analysis. So under regression we are talking about causation. So please take note of that. So let's go back and do some real quick intro to correlation. So correlations we say is technically used to determine what a linear relationship that is between two variables. It allows you to find out if there is a statistical significant relationship between variables or not. So that is correlation. By regression, as I say, a statistical method used to describe the nature of the relationship. Into bracket what? Causation. Causation. Please take note. Causation between any two variables. It allows you to make predictions based on the relationship that exists between two variables. So correlation, there is a linear relationship. Please take note of these values or these terms. In correlation, there is linear relationship. However, correlation does not mean what? Causation. Take note, please. Causation. All right. So to investigate causation, we use what we call what? A regression analysis. Use what we call what? A regression analysis. And even help us make some predictions. So for example, that's why you may get these statisticians found in hospitals. They may get, let's say, a list of patients who have, let's say, asthmatic patients, and based on the data they can make prediction that if the population doesn't take these and these let's say rules and health measures in place, then in future or in some years to come, you can see that they can make some prediction. You can see that in years to come, people are going to get more, let's say, this kind of diseases or this kind of what ailment. So based on the previous information, they can make predictions and then find out. So that's why these correlation and regression statistics are very, very important. It helps statisticians. I mean, helps everybody, and using statisticians, it helps them get that information and make predictions about what is likely to occur in future. So it's out of these statistics principles and methods we use also determine when you are doing election, when you're having an election, make some predictions based on the figures they have derived and predict that, okay, based on this number of figures I've received, this person will win, that person will win. And at times it happens. They make predictions and then the predictions are perfectly right. Not that they are always 100%, but then based on the information that they can make some predictions. Some of their predictions are always what right, but not always 100%. So as you move along, you understand why correlation and regression are very, very important. And once you're also into regression, how you can actually make those predictions in that case. So please, let's take note of that. So, and here we are looking at just simple regression. We have two forms. We have simple and multiple, but we are just looking at simple regression in that. So in simple regression, we have two variables. Let me explain real quick. We have variable x match up to what? Variable y, or it can be y match up to variable what? X. Okay, so how you denote it? I mean, meaning that for us to get the values of x, y, it is this x that will influence what? The y. Okay, it is this x that will influence what? This y. Okay, so that is a simple regression. So a simple regression, you have two variables. We have y and b matched up with what? X in that case. So that is simple regression. So in simple regression analysis, so let me read so that you see what is here. So in simple regression analysis, there is a simple relation between two variables, an independent variable and dependent variable. So the y will be a dependent variable, and then the x will be the independent variable. That's why we will denote in that case. The independent variable is needed to predict the dependent variable. As I was saying, example, the relation between the year of experience of a salesman and the amount of sales he makes involves a simple relationship. Two variables, years of experience and then the amount of sales. So what will be the years of experience and what will be the amount of sales? So the amount of sales will be the dependent variable, and then the years of experience will be the independent variable in that case. So consider the relationship between two variables, an independent variable and the dependent variable, a relationship between. So you can make this inference. As I was saying, you can either use S or Y. It depends on the one that is influencing the other. You can use a variable to illustrate it and make it clear. So here they use what? X and X match up, meaning that X is the dependent variable that is influencing what? Y. Okay, so or between single explanatory variable and what? A response variable. So explanatory variable can also be called an independent variable, and a response variable is also what? A dependent variable. So based on the two variables, you can use any letters to present. But once I use x and y, some may use, let's say, a map up to what? B, meaning that a is independent variable and b is what? A dependent variable. So any values that you use makes it understandable, because they are variables. They will change. Actually, variables actually, per our introductory, as you said, variables are those values that will actually change. It's not fixed in that nature. So let's take note of that. So let's move on. Then you also have, we are just giving some introduction about multiple regression, idea about a multiple regression. So in a multiple regression, you have more than one independent variable influencing what? Another variable. Is called what? A dependent variable, and a whole lot. And so there's a diagram that explains a multiple regression analysis. Multiples of what? Independent variable actually explaining or influencing another variable called a dependent variable. That is why in that case that we actually want to denote. So this an equation that helps us to determine a simple linear regression model where the y is the dependent variable, the a is the intercept value of the regression line. If assuming x is 0, then you get the intercept of what? Y. So you're going to get y equal to what? A. If x is 0, you get y equal to A. So that is why we call A as an intercept value of a regression line. And then B is the slope of the line. The x is the independent variable in that case. So that is a model. And remember, this one is similar to the one that we were having at SS. Determine an equation of a straight line where we said is what? Ax plus what? B. Let me write it well here. Some use y is equal to ax plus b. Others also use y is equal to ms plus what? C. Right? Ms plus what? C. Any of them still makes what? And so you see this one is similar to what we had at the excess, where we are using y is equal to ms plus c, where we are determining what? Equation of a straight line. It's the same thing that we actually have in it here, so there is no difference in that case. Just that here we actually employ these to make some predictions based on the value, the variables that we are having in place. So let's take note. So in that too, there is a way that we can determine the values or individual components in the equation where we have y is equal to ax plus b. I'm saying that y is a dependent variable and others, in that case. So you see this diagram and you see this small diagram. You see the amount of x that is influencing the amount of what? Y. So you see that relation. That's why we're actually talking about causation. So in that case, so that is a relation that will actually, because this is just a simple linear regression, we assume that all the values of s can have influence, but that not all the case. We have multiple regressions, as we saw in the earlier on. We can have a number of independent variable influencing what? A dependent variable, and that will be a multiple regression in that case. So let's take note. So how do you also find what the individual? For example, a, that is the intercept. For you to find the a, this is the intercept. It is y bar, as has been noted, minus what? The slope multiplied by the x bar. Next one. So once you find your mean of y, you find your mean of x, and you know your slope, you are good to go. But then you can't determine the slope. You can't determine the slope if you don't know. If, I mean, you can't solve the value of what? The intercept of the regression line if you don't know the slope. So how do you also then find the slope? So you are saying that to find the intercept is what? The y bar minus the slope multiplied by what? The x bar, and the y bar and the x bar are the means of what? These two values. Find the average of the, and we know how to find the average. So once you find the average, then you are good to go. Then the b, that is the slope. This is how you find the slope. You see, when we were finding the coefficient of correlation, we said it is a summation of x minus x bar bracket close multiplied by y minus y bar all close. That is summation all over the square root of the summation of x minus x bar all squared multiplied by the summation of y minus y bar all squared. You see, when we were finding the b here, we just take that of the coefficient of correlation, the numerator. You see, you have taken out the numerator. In that case, you can refer back in this video. You can refer. This was what was on the numerator for the coefficient correlation: x minus s bar minus y bar minus y bar. Yes, and then the denominator was the 2 all square, but you just take what? The summation of x minus s bar all squared. So this is how you also find the slope. You can also use this to find what? The slope. But then any way that you go, you still get the same result. So let's take note of that. So once you're able to find the slope, then you can work your way around, because you can easily find your y bar and the x bar, which is the average or the mean in that case. So let's take note of that. And then that is actually what you need to know in that case. So let's take note. So let's move on. And there's also what we call residual. There's also what we call a residual standard deviation, or what's error. There's also another statistical approach that we use to determine whether a group of variables and values fit perfectly on a straight line or not. We just find the standard deviation of the variables, and then we are good to go. And how do you find the residual error? It is being denoted by what? A small e, like this. And how do you determine this value? Is what? The observed value minus what? The predicted what value. The predicted value here is your actually the values that you want to actually you have predicted, sorry, is the values that you have actually what? Based on the regression equation. Okay, is the value you have actually predicted. So you compare that predicted value with the observed value, that is the y, the original value that was actually given in the question. You compare if there is a difference between the two values, then you can know that if that difference is resulting in a negative error or a positive what error. If it's a positive error, then it's a positive deviation. If it's a negative, then it's a negative for deviation. So let's take note of that. So as I was saying, in regression analysis, the difference between observed values of a dependent variable and a predicted value is called a residual. And I was saying that residual is another approach that helps us to determine how well two values or two variables and their values lies perfectly on a regression line or not. Actually help us. And how do you actually determine that? You determine by comparing the original value was given in to you, compare with the predicted value based from the regression equation that you computed, and you can determine that. So this is what we are actually talking about, a residual, standard deviation, or an error. So it's important to understand residual, as I was saying, because they show how accurate a mathematical function such as a line is represented a set of data. All right, so once you're able to know the residual, you can know that this line actually perfectly reflects this data that you're actually talking about, or it does not reflect it based on the standard deviation or the errors that you actually computed. And to find that, to find a residual, you must take the predicted value. I think we just met it just here, your observed value minus your predicted value. So that is more that you are trying to talk about. So to find how a set of data fits a particular regression line and accurately reflects its predicted values from regression line, as I was saying, there is a need to estimate a standard deviation. A standard deviation. A standard deviation will help us to know how well the set of data values actually reflect the regression line that you have in between two variables. Okay, so find a standard deviation of a residual in order to give you a good picture and accurately make a better judgment about a set of data that has been used. So that is actually why we engage in residuals. That help us to make a better judgment and accurately know how two variables values actually represent, or the regression line that we derive from these variables actually reflects the values that we are studying. So through the residuals, we can make those judgments, and then those accurate information can be actually represented in that case. So let's take note of that. So how do you then find the standard deviation of a residual? To find a standard deviation of a residual, it is the root mean square, right? The root mean square. So first of all, find the error. How do you find it? The error is what? The observed value minus the predicted value. The observed value minus the predicted value, which is e, which is equal to your y minus your this sign, right? So your observed value minus the predicted value. Once you find that, then you come and find the square of the error. Once you find the square of the error, then you find the mean of all the values and you take the square root of it. So you just take them in that backward. So first of all, find the error. After you find the error, you square the error. After you squaring the error, then you find the mean of the error, then you take the square root. That's what I actually wanted to denote here. So this is the formula that denotes the standard deviation that help us to know or make a good picture of how well variables actually reflect each regression line, or how a regression line reflects each variables to us to make a better judgment and make good decisions in that case. So let's take notes of that. That is the formula in that case. So these are concluding remarks. the smaller the standard deviation, the better the set of data fit the regression line, because that is true. Because the more you get a higher standard deviation, meaning that that set of data doesn't reflect the regression line, it's farther away. But if you get a small, meaning that your margin of error is very small, and so we can denote and make better conclusion and judgment that this set of data reflects its regression line and help us to make better predictions. So you can clearly see that all the predictions we make will be higher accuracy. The accuracy will very, very what high as compared to where we have what a bigger standard deviation, which is what a figure that you need to know. So the better the set, so the smaller the standard deviation, the better the set of data fit a regression line. That's line of best fit between two odd variables, and vice versa. Is very large or big standard deviation value, then is actually don't reflect or fit well with the line of best fit in terms of the values that we're actually talking about. So this is where we bring an end to correlation and regression. So thank you once again for watching this video. If you was helpful to you, please consider to subscribe, like, and share. So if you have any question, to put in the comment section form, and I'll give you a response to that. So I'll see you in the next video where we discuss practical questions on